Hello friends, welcome back to my YouTube channel named Electronics Engineering by Worship. Differential circuit using op-amp. A circuit that performs the mathematical differentiation of input signal is called differentiator. The output of integrator is proportional to the rate of change of its input signal. The diagram is shown below as positive terminal varies negative to ground, and we have an integrator as C, current IC, V is the input, and we also have a feedback resistance RF with the input current IF with the output voltage V naught T. So from step of ultrasound VD is 0, and we also know VA minus VB is 0, so VA is equal to VB, but VB is 0, so therefore VA is 0, equation 1. Now apply KCL at node A, so IC is equal to IF, so we can write C into D bracket में V minus VA by dt is equal to VA minus V naught by RF. VA is 0, so D into bracket में V in by dt is equal to minus the V naught upon RF. Then say V naught is equal to minus the RF into C. D bracket में V in by dt, or V naught is directly proportional to D bracket में V in by dt. The output waveform of the differentiator is shown below, and it is used to convert the triangle into the square. So application would be first it is used to generate square waveform. Second, it is also used in digital to analog converter circuit. Third, it is used as high pass filter. Difference of separator amplifier. Circuit that amplify the difference between two input signals to difference amplifier. Separator amplifier. The diagram is shown below. Having the VB voltage, having the feedback resistance RF with current I2, having also the voltage V2, the resistance R1, current I1, and we have point voltage VA and current I3 with resistance R1 with voltage V1, and resistance RF with current I4 with output voltage V0. So from concept of ultrasound, VD is 0, so VA minus VB also 0, so we can write VA minus VA is equal to VB, equation 1. Now apply KCL at node B. So it would be I1 is equal to I2, so we can write V2 minus VB by R1 is equal to VB minus 0 by RF, right? So it would be V2 by R1 is equal to VB by RF plus VB by R1. So we can also write V2 by R1 is equal to VB common, and we take LCM of 1 by RF plus 1 by R1. So it would be bracket में R1 plus RF upon RF R1. So it would be VB is equal to RF by R1 plus RF bracket में into V2. It is equation 13. Now apply KCL at node A. So it would be I3 is equal to I4. Be V1 minus VA by R1 and is equal to VA minus V naught by RF. So we can write V1 by R1 minus VA by R1 is equal to VA by RF minus V naught by RF. So we can also write V naught by RF is equal to VA by RF plus VA by R1 minus VA1 by R1. So it would be V naught by RF is equal to take common VA and we take LCM of 1 by RF plus 1 by R1. It would be VA into bracket में R1 plus RF upon R1 RF bracket close minus V1 by R1, but VA is equal to VB, so it would be V naught by RF is equal to VA is equal to RF by R1 plus RF, so we put VA is equal to R1 RF by R1 plus RF into V2 bracket में R1 plus RF into R1 RF minus V1 by R1, right? V naught is equal to RF by R1 into V2 minus V1. So circuit voltage is a difference or a subtractor amplifier, or if R1 is equal to RF, so V naught is equal to V2 minus V1. So circuit voltage is a difference or subtractor. So at the end, thank you so much everyone, and please like, comment, share, and don't forget to subscribe to my channel and press the bell icon of the channel.